And first thing we've got to do is we're going to find the speed of the particle at t equals 3. So this is straightforward enough because we already know that the velocity function is here, and velocity at 3 is 6 times 3 squared minus 42 times 3 plus 60. Okay, and then if you put all that into your calculator, that's going to come to negative 12. Okay, now this is where things get a little bit sticky because you've got to be careful with the wording. It doesn't ask for the velocity, it asks for the speed. So the velocity is negative 12 meters per second. That means that it's moving towards the left at 12 meters per second. The question doesn't ask for the velocity, the question asks for the speed. So the speed is just 12 meters per second. And that's the same reason why this, whether it's speeding up or slowing down, is a little bit more tricky. It's not the same as asking, is the acceleration positive or negative? We need to consider the direction of travel as well. Now, if we go back to our graph, okay, from this point here to about this point here, what's happening is it's actually speeding up, okay? It's moving towards the left at a quicker and quicker rate, okay? And then at some point around here, it starts slowing down. It starts slowing down. It's moving left, but it's moving slower and slower and slower, and then it changes direction, okay? So between here and here, if we trace this down to the derivative function, okay? Basically, between here and here, the derivative, in other words, the velocity, is negative. The velocity is negative, and the acceleration is negative. Now, when these two match, if the velocity and the acceleration are both negative, it means that it is slowing. It means that it is speeding up. Okay, so even though they're both negative, because they're the same sign, we know it's speeding up. Whereas here it's slowing down, and what you'll notice is that the velocity is negative and the acceleration is positive. So when these two don't match, when one is positive and one is negative, then that means it's slowing down. And that's an extra rule that we really need to know. So we're going to have to make a note of that in your notes. Okay? So underneath here, I want you to just make a note that if velocity and acceleration have the same sign, i.e. positive, negative, then the object is speeding up. Okay, whether or not the velocity is positive or negative, it's almost irrelevant, because remember, negative velocity can still mean, and a negative acceleration can still mean it's increasing its actual speed. It's just the direction is changing. And if velocity and acceleration have different signs, then the object is slowing down. Okay, I guess another way of thinking about this is if the velocity and the acceleration are going in opposite directions, then they're working against each other. Yeah, so whichever direction the velocity is going, the acceleration is going in the other direction, and therefore it's slowing down. Whereas if velocity is positive and the acceleration is making it more positive, then it must be speeding up. Whereas if velocity is negative and the acceleration is also negative, then it's making it even more negative, and it's going even quicker, just in a different direction. So what we need to do for A is actually we need to think about, if we think about the velocity, okay, so we knew from last time we solved this equation, and last time we knew that the velocity had two roots, had a root at 2 and 5, so the velocity was 0 at 2 and 5, and I can't quite remember now which way around it was, but if I look at the graph, I can see that before 2 the velocity is positive, in between 2 and 5 the velocity is negative, and after 5 the velocity is positive. Okay, so if I go back to my notebook, okay, so velocity was positive, negative, and then positive. Now, if it's a calculator paper, you can get that from the graph. If it's a non-calculator paper, then you have to do the working by hand and substitute in some numbers to find out. And then for the acceleration, well, we need to work out what the key points of the acceleration are now. Now, you know from the graph already what it is, or you could look at the graph, but we're going to assume this is a non-calculator paper. So the acceleration is 12t minus 42. Yeah, that's from differentiating. So basically 12t minus 42. Let's find out when it changes direction. 12t is equal to 42. So t is equal to 42 divided by 12 is 3.5. Okay, so there's your key bits on the acceleration, 3.5. Now, let's say that t equals 1. So before 3.5, when t equals 1, the velocity at 1 is equal to 12 times 1 minus 42. So the velocity is negative 30. So I know that it is negative. All through here it's negative. And let's choose a point after 3.5. Let's choose t equals 4. So when t equals 4, v of 4 is 12 times 4 minus 42, which is 48. Minus 42 is 6. So here it is positive, okay? Positive all the way through. So let's look at when the signs match. The signs match here after 5. Yeah, they're both positive. They don't match here, okay? So between 2 and, between 2 and 3.5 they match. They're both negative, 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 okay? So they do match there and there. They don't match, so I'm just going to cross them out here because one's negative, one's positive. And here they don't match either, okay? So I can conclude that it is speeding up when t is between 2 and 3.5 and when t is greater than 5, and it is slowing down when t is less than 2 and when t is between 3.5 and 5, yeah, in these areas here. Also notice that I could say it's slowing down when t is between 0 and 2, but it's kind of taken as a given that the time will never be less than 0.